Welcome back. This is lesson 13.2, part 2, box plots. I will be able to create a box plot for any data set. I will also be able to analyze box plots to make sense of and compare data sets. So all this vocabulary, we're going to add one to our vocabulary sheet. So if you'll pull that out. Okay, the one we're going to add is Boxplot. Boxplot is a type of graph that shows data, I should say shows how data are spread across a number line. Across the number line using quartiles. Okay, now that we've done the box plot, let's review these other definitions we've talked about. Variability is how spread out data set is. Minimum is the lowest value in a data set. Maximum is the highest value in the data set. Median is the middle number when they're in order from least to greatest. Upper quartile is the median of the upper half. Lower quartile is the median of the lower half. The range is how spread out data are. So we always take the highest value minus the lowest value. Find that difference. And the interquartile range is the difference between the upper quartile and the lower quartile. Alright, we have some data here. It says Grant wants to make a box plot to compare the scores of his favorite football team this season. Their scores were, okay, we got a bunch of them. Before we do anything, let's put them in order from least to greatest. So, the lowest score they had was 6. Next lowest they had was 7. Let's see, after 7, looks like 10. After 10, looks like 14. That's everything in the teens. So 21 looks like the next, and I see 1, 2, 3, 4 21s. Next I see 2 24s. Looks like they started their season off well and then kind of flopped a little there, didn't they? If this is in order. Let's see, 24, what's after 24? 27. 35. 36 and 36, so we got 2 of those. 42 and 49. Alright, so now that we've done that, we can find the minimum, the maximum, lower quartile, median, upper quartile range, and interquartile range. It goes right back with what we did on the last journal. So the minimum is 6, the maximum is 49. Okay, we can't find the lower quartile or the upper quartile without finding the median first. So let's find the median. We got to cut it in half before we can cut it in half again on each side. Okay, just double checking. I have a bad habit of not paying attention. Alright, looks like 21 and 24 share that middle spot. So we're going to have to add those together and divide by 2. So 21 plus 24 divided by 2 equals 22.5. Okay, median of the lower half looks like 14 and 21 are fighting over the same place. So 14 plus 21 divided by 2, 17.5. So the lower quartile is at 17.5. The upper quartile shared between 35 and 36. So that's going to be 35.5 because that's halfway between 35 and 36. The range, 49 subtract 6 would give us 43. And the lower interquartile range, the range between the upper quartile and the lower quartile, so in other words, how far it spans between the middle half. 35.5 subtract 17.5, and that spans 18. Now, why is this useful? Well, when you're making a box plot, you're going to make a number line to cover all the values you have up here. Now, the problem is, I don't want a number from 6 all the way up to 49 by 1, so that'd be a pain in the rear. So what I want to do is, it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. Maybe pick something that I can number by, so maybe 0 to 50 if I number by 5s. So if I start 0 here, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That will fit everything I need. I also need to label this. If I were just to give out this box plot score, a box plot to somebody, they'd say that's cool, but what does it represent? So this is scores of Grant's favorite team. Scores of Grant's favorite football team. I don't know what team it was, but now it's got a label. We know what we're talking about. Alright, now a box plot is sometimes also called a box and whisker plot. They kind of look like something an alien would draw. But I'll explain where each piece comes from. So you need to know the 5 pieces. The 5 pieces that make up, we're going to make 5 dots. We're going to make a dot for the minimum. So what you're going to do is you're going to find 6 on the number line, which would be just bigger than 5, and you're going to put a dot up here above the number line. Okay, we're going to put our maximum, which is at 49, so just below 50, put a dot. You also need to put a dot for the lower quartile at 17.5. 17.5 would be right here in the middle of 15 and 20. The median at 22.5. So 22.5 is halfway between 20 and 25 actually. And 35.5 would be just barely bigger than 35. Okay, you've got those 5 data points. Now the box and whisker plot, you connect the inner quartiles, inner meaning the 2 in the middle. So what we're going to do is we're going to draw a box out of these. So you're going to put a line through these and connect them. Here's my box. Now the reason they call this box and whisker plot is we're then going to connect this, and we're going to connect this with a line. That's a box plot. Like I said, they kind of look like something an alien would draw. But how can I read this? What is the point? Well, what it's showing is box plots split all the data into 4. See how there are 4 numbers here, 4 numbers here, 4 numbers here, and 4 numbers here. We're comparing how spread out everything is. So looking at this carefully, do you see across the number line how spread out this one is? So these numbers in the first quarter are spread out over, well, about 12 numbers there. The second quarter, look, they're even closer together. So see how this is tinier? This is less spread out than this one is. Now remember, there's still 40, there's still 4 numbers in each one. This is just how spread out it is. So the least spread out they had was in this area. Well, actually, everything was 21. So everything fits in between here. Then the next area spread, and then the next area spread. So it actually looks like they're fairly evenly spread out, except for right in here. They have a cluster, and you can see that at 21. All right, let's see what Miles finds. So Miles makes a box plot to compare the scores of his favorite football team this season. Let's go ahead and organize those, and then we'll talk about how we can compare these box plots. So Miles wants to make, oh, I already said that. So we got these scores. What is the lowest score we see here? Wow. I dare say that his team is probably a bit better than Grant's this season. I see 21 as the lowest. So I see two 21s. Okay, after 21, there's a 28. Anything lower than 28? Yes, there's a 24. And 28 would be next. Okay, after 28, I see a 30. I don't see any other 30s, so 31, 2, 3. Okay, I think 35 is the next lowest I've seen. So I see 1, 2, 3 35s. I see a 36. Another 36. 37. 38, no. 39, yes. See a 40. We have a 42, 1, 2, 3 42s. That looks like all of our numbers. Alright, let's find the minimum. 21. Maximum 42. Lower median first before we can find these ones. So find the median. So 35 and 36. So that's going to give me 35.5. If I add them together, divide by 2. Let's see. Lower quartile. Median of the lower half. Fighting between 28 and 30. 28 plus 30 divided by 2, or halfway between the two, is going to give me 29. Upper quartile, 39 and 40. Add those together, divide by 2. We're going to end up with 39.5. The range, upper minus lower, 42 minus 21 is 21. And interquartile range, oh, I should have written these up here. So this is 30, or 29. And this one was 39.5. All right, let's make, oh, the interquartile range, 39.5 minus 29. $10.5. So, looks like we span from 21 up to 42. Because I'm comparing these, I'm going to make the same number line, so I'm going to go 0 to 50 again. 5, 10, 15, 20. If I wasn't comparing them, then I probably would have started at 20 and gone to 45 on the number line and numbered it smaller, just because the smaller you can number it, the more accurate it is to read. But because I'm comparing Grant's team scores to Miles' team scores, I want to keep it so they look the same. If not, this one would look bigger and might be misleading. Okay, we've got to label it. So this is scores of Miles' favorite team. now it has a title. Let's go ahead and make our box plot. You need these 5 pieces. So we got to have the minimum, which would be at 21, so just a little bit above 20. Maximum at 42, so a little bit ahead of 40. Lower or median, lower quartile is at 29, so just below 30 here. Median at 35.5, so just a bit bigger than 35. And 39.5, so just a little bit below 40. Okay, the box is made up of the lower quartile, the median, and the upper quartile. Then we make the whiskers to connect the lowest value and the highest value. Alright, so remember we're comparing 2 football teams. I even made my number lines exactly the same. Look at Grant's compared to Miles. Now there's a couple of more things I want to teach you about this. Remember, this was splitting all their data into quarters, right? Well, think percentages. A quarter is 25%, so this is 25% of the data. This would be another 25% of the data. This would be another 25% of the data. And this would be another 25% of the data. Well, if that's the case, 50% of his team's scores were between 29 and 39.5. So over half of the games that his team played, their scores were in that little section. Whereas Grant's, same idea, half of his team scored between 17 and 35.5. So do you see how much more spread out that is than the middle half of Miles' data? Okay, another one we could say is that 75% of 75, look what I'm doing, 25, 50, 75, so 3/4 of his data. 75% of Grant's teams scored 35.5 points or lower. Well, I can say that 75% of his scored 29 or higher, because here's a quarter, and here's a quarter. Look at that. That would be 75%. So each one of these represents 25% of the data. All right, let's answer these questions down here. It says, whose team was the most consistent? Which one is the least spread out? Well, that would be Miles. Why? The data is less spread out. So if I were voting for a team to win, I would probably guess Miles, if these two were in a game against each other, I would probably guess for Miles' team to win because like they're more consistently up here in the upper range than his team was. His team was all over the board. Now it says whose team scored the highest? Well, that would be Grant's team. They had a score of 49, which is higher than his score of 42. Why? 49 is higher than 42. Whose team had the largest IQR, interquartile range? 18 is larger than 10.5. So that would mean Grant's did. What does this mean about the team compared to the other team? It means the middle half of Grant's data, or well, let's say Grant's scores, is, I'm just going to put this, is greater spread than Miles. So it's more spread out, which means Grant's team was more likely to have a lower score or a higher score. However, his is more consistent. So if I were going to be rooting for a team to win, there's a better chance of Miles' team winning than Grant's based on what we can see from their scores. This one had a good day, but more consistently had lots down here in the lower ranges, where his were all pretty close together. Alright, it says, based on these box plots, which team is more likely to win if they were to play each other? I guess that's what I've been saying this time, haven't I? Miles' team, because they are more likely to score above, look at the medians here. This had a median of 35. This team had a median of 22. So because of that, half of their scores were above 35 and half of their scores were above 22. So I'm going to say they're more likely to score above 35 points than Grant's. We can see that from the spread. So hopefully that gives you an idea how to use and create box plots. Rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.